Hello. We learned three ways to conduct hypothesis testing: p-value approach, t-statistic approach, and the critical value approach. And we are going to apply those methods to two numerical examples from here. So first example is about I-beam. I-beams are kinds of steel beams used in construction, look like this. It's called I-beam because it looks like I in the cross section. So it's used to like for construction. So there are standard sizes for I-beams. So the smallest I-beam should be is the standard size. Smallest standard size is 80 millimeters tall. So this height is 80 millimeters. 80 millimeters. That's the smallest one. So you would like to test if I-beams manufactured by a factory have the correct size or not. So that is what we are going to consider in this example. So I set up the hypothesis in this way. The null hypothesis is mu equals 80 millimeters. So the expected, when I choose a random I-beam, its height, I measure its height, which is the random variable, and its expected value should be 80 millimeters. So we expected height is 80 millimeters, and the alternative hypothesis is simple negation of that, so it's not 80 millimeters. And so given those hypotheses, we randomly choose random sampled 400 I-beams and measured their heights and obtained the sample average of 79 millimeters and say measurement error of 10 millimeters. So of course 10 millimeters sounds too much, but keep it simple. So I just choose a simple number. By the way, so okay, the sample average is 79 millimeters. Then my question is, okay, 79 millimeters is 1 millimeter shorter than what I expected. Then we have to decide if that 1 millimeter difference is significant or not. If not, we can ignore the difference and I will pass it. So the I-beams are okay. Otherwise, if 1 millimeter is not ignorable, if it's not just a measurement error, then you have to stop the construction. It could be a safety hazard. It could be dangerous. So we are going to try t-statistic, p-value, and critical value approaches with the same numbers. So first tab is to calculate the t-statistic. Find the t-statistic of this test given those observations. Pause the video and try it. Okay, I will show you the answer. Remember, the t-statistic is basically the difference between the sample average, which is 79, and your hypothesis, which is 80, and standardize this by the standard error. Divide by s over square root n. Here s was the measurement error standard deviation, which is 10, and sample size was 400. Square root of that was 20. So in the end, simple, minus 2. So t-statistic is minus 2. So the 1 millimeter, when you consider the standard error, it can be standardized into minus 2. So now then, so we are going to compare. So suppose that a program calculates t-statistic for you. So you obtain this from a software. Then how can you make the decision? So now you have to make the decision. So suppose that the significance level is given as 1%. Then what is what is the decision rule? When would you reject the null hypothesis? Okay, think about this. Okay, the answer is E. So first, you like for 1% significance level, top alpha over 2 probability value is 0.05. So you have to go to 0.5%, top 0.5% value, which is 2.58 according to normal distribution calculator. So this is the cutoff level, and also what else? Another thing you have to know is the direction of the inequality should be this way. So if the difference is larger than the cutoff, then you are going to reject. So we are looking for the condition to reject. So these two inequalities does not make any sense. So because t is the difference and you reject when the difference is too large, then you know the options are B, D, or E. Among them, 1% significance level implies 2.58. So the answer is 2.58. Then, okay, now you calculated the t statistic and you know the decision rule. Then what is your decision? What is the final decision? Okay. Okay, the answer is, you do not reject. Because remember, the cutoff is 2.58. That means as long as the difference is smaller than plus minus 2.58, then you do not reject the null hypothesis. And yes, it's not, and the t statistic is within the cutoff, so you do not reject it. Yes, it's smaller than 2.58, so you do not reject the hypothesis. So the answer is no. This is the typical process of doing a hypothesis testing. So by the way, there is another typo. I don't know, somehow there are a lot of typos in this slides. Sorry about that. And now I will ask you this way. What happens if alpha increases to 10%? If the significance level was 10%, how would the decision change? And when, a typo again here. So when alpha is 10%, the threshold should be 0.05 here, or maybe I changed the numbers. So the cutoff becomes 1.64. So you are rejecting much more when alpha increases. So your critical values get closer to the hypothesis. So you do not allow much margin. Smaller differences will be rejected. So now minus 2 is greater than the threshold, 1.64. So the difference is too large. So your null hypothesis should be rejected at 10%, right? That's what happens when you increase the significance level. And then, so far, we consider the t-statistic approach, and also equivalent to the t-statistic approach is the p-value approach. Now, then calculate the p-value. Pause the video, and I'll show the answer. The p-value is calculated this way. We obtained a t-statistic of -2, so the p-value is more different from the null hypothesis. So smaller than -2 or greater than +2, right? So the probability in each side is 2.275. So on the negative side, on the positive side, so the sum is 4.55%. So this is the p-value approach, which means if you use a software based on the p-value approach, then you are going to get this result from the data. And then given this outcome, p-value, among the 3 common significance levels, at which level the null hypothesis is rejected? Think about this. When the null hypothesis would be rejected? The answer is 5 and 10%. So remember, the null hypothesis is rejected if the p-value, so alpha is capturing the how much you are going to reject from the top, and p-value is showing the ranking. So that means your outcome of -2 is top 4.55% outcome. It is top 4.5% most different outcome from your null hypothesis. Therefore, if you are going to reject 5%, top 5%, or top 10%, you are going to be rejected. Top 4.5% will be rejected at these two levels. However, if you are rejecting only 1%, then you can survive. You are not rejected. So it is consistent with what we have seen here. So when we considered 1%, it was not rejected, but when you increase alpha to 10%, it is rejected. So t-statistic approach and the p-value approach are equivalent to each other by construction. And finally, you may consider critical value approach. Now I'm going to fix alpha to 1% because you need alpha to calculate the critical values. And yes, calculate the critical values. What's the critical values? The answer is, when you use 1% significance level, the z-value is 2.58. So using this, other than this, all the numbers are straightforward. The null hypothesis implies 80, standard deviation, and sample size. So just apply the numbers, calculate. That shows the margin is at 1% significance level, the margin is 1.29 millimeters. So plus minus 1.29 millimeters is allowed around the standard correct size. So now, by the way, again, here in this calculation, what you did not use is 79. The observed sample average is not calculated here, not used here. So again, as I said, given the same critical values, you can apply that to like this brand and to another brand and to another factory or later or like another shipment, something like that. So you may use the same critical values to repeated inspections. This is the advantage of using the critical value approach. By the way, so we obtained critical values like this, and we observed a sample average of 79 millimeters. Then do you reject the null or not? The answer is no, we do not reject. Because as I said, we allow, so if the sample average is between these 2 points, then they are close enough to 80, the correct size, so we do not reject the null hypothesis. And yes, your observed sample average is in between those two critical values, so you do not reject the null hypothesis. And again, this is consistent because we considered 1% significance level, so the result should be consistent with the p-value and the t-statistic approaches. Yes, we did not reject the null hypothesis at 1%. And finally, when you increase the significance level to 10%, how would the critical values change? Try this. The answer is only this part changes. When alpha changes, this z value should change to 1.64. Otherwise, all the same. And as a result, because of the change in alpha, now the allowance is much smaller. Earlier at 1%, we allowed 1.29 plus minus 1.29, but now we allow only plus minus 0.82. 0.82 is the maximum margin we accept. So in this case, the lower critical value is 79.18, which means the observed sample average is lower than the lower critical value. It is outside, so your acceptance region is like this much, but your observation is outside of that, right? Therefore, now you have to reject your null hypothesis because now the significance level is greater. It makes sense, and also it is consistent with our previous results. So this is a simple illustration of how we apply 3 approaches to real data in a very simple example. And finally, here is another final question. I'm going to let you do it at the end of this video, and we'll show you the answer in the next one. So now what I'm going to do is I'm going to change the null hypothesis. So I believe that this brand has smaller size. So I believe that this brand is making I-beams smaller size at 78 millimeters, which is dangerous. So then what would be the decision at 1% with this null hypothesis? It doesn't matter which approach you use, just try whatever you like and see what is your conclusion. I'm going to show you the answer in the next one. So see you later.